Okay, now we're going to do the Poisson distribution problems. These are in 7.5, and this is the general formula for calculating it. This is e to the negative lambda times lambda to the power of x divided by x factorial. And lambda is just another way we say mean. So we use in the Poisson distribution, okay? Now, this first example is the simplest kind of problem, the one where they're asking us for some exact value. So we're just looking for the exact, or for the probability when x equals 4. So you're putting these values in the calculator, and just to kind of let you know, if you're using a scientific calculator, these would be the steps that you would follow, okay? And by scientific calculator, I mean something like this, okay? So for this type of problem that I have right here, you would start with the 3.4, and then make it negative by using this button, and then use second ln times 3.4. I'm just doing this right here, 3.4. Then I'm going to raise that 3.4 to the 4th power by using this y to the x key. So I'm just pressing it, and then I'm going to press the 4, and then I'm going to divide this by 4 factorial, which is 4 times 3 times 2 times 1, which is 24. So I already pressed divide, and now I'm going to press 24 equals. And this would be the answer for this problem, okay? So just write down those steps so you'll know how to use that calculator. If you were doing this problem on the graphing calculator, these would be the steps that we would use. So for the same type of problem, we would use the second, here's the ln, so we would go second ln, and then we would, see how it opens a little window for the exponent? When you're going to use negative and make it negative 3.4, be sure you use this negative, not the minus sign, but this negative 3.4. And then use this little right arrow key to move your cursor, and then times. And then we want to have 3.4 to the power of 4. So we're going to go 3.4, and we're going to raise it to the power of 4, and then arrow to the right again to move your cursor down. Hit the divide key, and then 24, and then enter. And then you get your answer to that calculation. Okay? So again, the one that has x is equal to a number, that's the simplest type of problem. Then we move on to these that aren't that simple, and you have to know you have to know how to do these. So we've got a couple of complications going on here. One is they give us a mean per day, but they ask about a probability per week. So that's one thing that you're going to deal with, and how you're going to do that is you're going to think about this as 0.4 per 1 day equals what per 7 days. And how we get this 2.8 is thinking about 7 times 1 gives us 7, and 7 times 0.4 gives us 2.8. So this is the lambda that we're going to use in this problem. That's one complication. The other is this probability. They want to know the probability that a computer will crash more than 4 times. So this is how we would write that. What's the probability that x is greater than 4? Now, the Poisson distribution is a little bit different. We don't really know how many trials we have here, but we can kind of get an idea of how to think about this problem. So I just wrote some number of trials out to 6, And I'm indicating here what they're asking me to find. The probabilities when x is greater than 4. We don't know, this goes out into infinity. So in a Poisson, you always want to be solving for, you want your probability in your formula to be x is less than or equal to a number. Okay, so in this case, instead of solving for the probability that x is greater than 4, like it asks for, we're going to make an equivalent equation that is 1 minus the probability that x is less than or equal to 4. So we're going to find these probabilities, and then we're going to do 1 minus that. And that is what I have done right here. And here is the calculations for that. All I did was calculate for each value of x that was equal to 4 or less than 4, and just follow the formula, add these numbers together. When you get here and add, you can round to 4 digits, and then don't forget to go back and do 1 minus that number to get your final answer. Okay? Then we have this type of distribution. Now, this one is already in the less than or equal to form. So I just left my big old mistake here just so you could see that sometimes we can do a lot of math and it seems like we're doing the right thing, but we keep getting the wrong answer. So that's when it's time to ask for help. So even though it looks like it would be easier to do 1 minus these 3 probabilities, in fact, because the way the Poisson works, we have to do this one. We have to find all of these probabilities. We can only solve the Poisson if x is less than or equal to a number. Okay, so there's the calculations for that. And by now, hopefully that all looks familiar. It's just the same thing that we've been doing, and then adding the numbers, and then well, this is the final answer. We didn't have to do any subtraction. So it was just probability of x being less than or equal to 5. We're adding all these probabilities. That's what we're doing here. There's the probabilities, and now we've added them. So that is the answer for that.